Before I show you the tutorial, let me say, let me make an announcement. Okay, the announcement is about uh, just a minute, guys. Let me move. All right, the announcement is about the course website. The course website contains everything that you need to know about this course. So for example, the videos after every session are contained in the course website. Like the video after the review session that we did yesterday, it are contained over here. This is the YouTube version, and this is the UOM version. And the video after the tutorial session yesterday are contained in these two links, right? So I do not use Blackboard because I find it very inconvenient to use Blackboard. And for that reason, I put all the videos on this course website, which is this one, right? And you don't need a login password or username to access this site. So after every session, after whether it's a review session or whether it's a tutorial session, you can see the links for the videos in this website, right? The link will contain a YouTube video and also a UOM video, right? So if you are in China, for example, you can access the UOM video, but because YouTube is banned in China, right? All right, now let's go to the tutorial. The tutorial sheet today is contained in this link, which is this one, right? So the tutorial today is about introduction to R. Okay, introduction to R. So what I will do is I will take you through this line by line and do some of the exercises that we need to do, right, during this session, right? Now, before that, you need to install R. So, I mean, I already have R installed. So if you don't have R installed in your computer, this is what you need to do. So what you need to do is to open a browser. So let me open this browser and type this address, www.r-project.org. And then you go into download R, right click here, you will come to this page. This is a mirror page. It contains links to the R package for different countries. So you go, like I'm in the UK right now, so I will go here and click here. But you may be in a different country. So depending on the country you are in, you choose the corresponding mirror. Okay, once you click here, you will get to this. And this is an online version. What I'm talking about is an online version, Michael. All right. So there are three options here. There's a one for Linux, there's one for Mac, and there's one for Windows. So since I'm using Windows, I will click on Windows, right? And then if you are installing R for the first time, you will click here, right? And then it will take you through a few steps to install R in your computer, right? It's very easy to do. It's very easy to do. I mean, anybody can do it, right? All right, so I'm not going to install it because I already have R in my computer, right? Okay, so let me close this. Now, once you install R, what you need to do is the following. You go into Start button, and then you choose, you go down the menu and you choose R here. There are two different versions. One is called 386, the other one is called 64. And you will choose the 64 one because that's more powerful, right? So you click on the 64 version, right? And it will come up with this window. This is the R command window, right? So, okay, now what I'm going to take you, so I'm going to take you through the tutorial sheet line by line and show you how to do things, right? So like first thing is like help. Like if you want to help on anything, like for example, if you want to help on plot, plot is a command in R, right? And if you want to help on that, you just type help in brackets plot, right? And then press enter. And it will show you, it will show you how to use the command plot, right? Okay. Okay. Now, if you want to like add two numbers, this is what you do, right? This is what you do if you want to add two numbers. And if you want to like say add and subtract, this is what you do. And if you want to multiply two numbers, say 25 and 20, this is what you do. And if you want to divide two numbers, say this is the operation for that. Okay. And if you want exponentiation, like 4 power 3 is 64, right? Okay, and if you want to like combine addition and multiplication together, then you write like this. So in this case, guys, the computer will do the multiplication first, then division, and then the summation, right? I'm sure you know that there's an order for the operations. So the first will be multiplication, division, and then summation. There is a number called pi in R, which is, as all of you know, pi is 3.141593 up to 6 decimal places, right? And excuse me, guys, what's going on? Am I okay? If anybody wants to enter, just okay. Right. If you want to multiply pi by say 100, excuse me. If you want to multiply pi by 100, this is what you will do. So it's pi times 10 to the power 2 is 314.1593, right? And all right, now let me show you how to create objects in R. So you can, in R, you can call an object any name you like. So here I created an object called A, and it's assigned, what's going on here? Just a minute. Just a minute, guys. Is somebody still coming? Oh, no, I can't see anyone. Oh, there is one in the waiting room. Oh, okay. Okay, let me go back to share screen. Okay, so if you want to assign an object, so in this case, what I've done is assign the value 23 to an object A. So if you type A is equal to 23, right? And in this case, what I have done is to assign the value 25 to an object named B. So if you type B is 25. So A times B is 575. A divided by B is 0.92. And you can also do this, like you can assign an object called C and let it be, say, 10 times A plus B, right? Then C will be 255, right? I mean, you can call the objects any name you like. You don't need to call it A, B, and C. You can call it like any name in English, any language, right? You can call it. Now ls means list. So ls. So let me excuse me, guys. Sorry. Let me change this to you. So ls means list all objects in R. So when you type ls, it lists all the objects that you created so far in R. So here we have created 3 objects so far, named A, B, and C, right? Okay. So by the way, the number key is a command line. So anything that follows after this, anything that follows after the number key is a comment, right? Okay. Now, by the way, the RM key, RM stands for remove, right? So now, so RM denotes, means remove all objects in R, right? So now if you type ls, you will see there are no objects left in R because we have removed all 3 objects A, B, and C in R, right? Okay. Okay. Yeah, pi Robert is just the number pi. Okay. All right. Now there's another thing in R is that suppose you type x5. So that means x is assigned the value 5. Now if you type capital X, it will give you an error message because the reason for this error is because little x is different from capital X. So R is case sensitive, right? So a small letter is not the same as the capital letter, right? So you have to be careful whether you type a small letter or capital letter because they may mean different things in R, okay? Now, the next thing I'm gonna talk about is how to create vectors. Now, suppose you want to create a vector, say named X. To create a vector, you start with this command C and open bracket, and then you type the numbers you want to put in the vector. So say 1.4, 2.7, 4.9, 5.5, 7.8, 10.2, 14.2, 15, and 16. So what I have done here, guys, is to X denotes a vector of length 9, and it contains these elements 1.4, 2.7 up to 16, right? Okay, and there are a lot of things you can do with the vector. So for example, if you want to multiply every element in a vector with 2, this will produce this. And if you want to multiply by 2 and add 1, this is what you will get. If you want a reciprocal, this is what you will get. So 1 divided by x gives the reciprocal of each number in x, right? And there are also several commands that you can apply with the vector. So length of x is basically the number of elements in x. Mikhail, yeah, yes, I mean, the vector that I created is a column vector, yeah. It's basically a column vector. I mean, what you can do is, I'll talk about it later. Like there's a command called T of X, which uses the transpose. So here, T of X is a column vector. So when T means transpose, I'm sure transpose of a vector. So Mikhail, you can use the command T to get the transpose of a vector X, right? Okay, right. Now let's get back to X. So length of X denotes the how many elements you have in X, right? Or how many the length of the vector, right? And then you should do sort of X, S-O-R-T. That means it arranges the data from the smallest value to the largest value. So the smallest data point is 1.4, the largest is 16, right? All right. Now you should do sum of X. If you do sum of X, it will take the sum of all the values in X, right? And if you do mean of X, it will take the average of all the values in X, right? If you do var or variance of X, so this is the formula I talked about yesterday in the review session. So this is what this does is it computes the sample variance of X, right? Using the formula I gave you yesterday. If you do SD, SD stands for sample standard deviation. Standard deviation of X is this, right? And you can also compute the standard deviation by taking the square root of the variance. So you see these two answers are the same as they should. The standard deviation is the same as the square root of the variance, right? Okay. And you can also do this min. Min of X is just the smallest data point, and max of X is the largest data point, right? Okay. Right, so that's those are simple operations using vectors, right? Now, if suppose you want to access a certain element of a vector. So this is a vector containing 9 elements, right? Suppose you want to pick out the third element, which is 4.9. So this is 1, 2, 3. The third element is 4.9. And suppose you want to remove the third element from the vector, then you will get this. You see, I have removed 4.9 from this vector. So you get 1.4, 2.7, 5.5, etc. until 16. Right. Now, suppose you want the data from the second position to the fifth position. That means this is the second data point, third, fourth, fifth data point. So you get 2.7 up to 7.8, right? And suppose you want the data on the second, the fourth, and the eighth positions, then you get these, right? So the data in the second position is 2.7, the fourth position is 5.5, and the eighth position is 15, right? Now, let me retype X, okay? Now, suppose you want all the data that are greater than 12. So this will list all the data values in X which are greater than 12. So it will be just the last 3 data points which are greater than 12, right? Now, suppose you want all the data that is less than 2 or greater than 15. Now here, the vertical symbol here, the vertical symbol means or. So let me write type. So this means or, okay. So what you're looking for here, guys, is that you're looking for all the data that are less than 2 or greater than 15. So once again, you only have 2 data points, either 1.4 or 16. Yes, Alyssa, I'm recording every session. Every session I'm recording it, and after all the videos will be posted in the course website, not in Blackboard. I don't use Blackboard for posting videos. All right, so just go to the course website. I'm sure I showed you where it is, right? And you will see the videos posted there, right? All right, now X, suppose you want all the data that is greater than 6 and less than 12. So here, and sign, this sign here means and, right? So here you're looking for X greater than 6 and less than 12. So once again, there are only 2 data points, 7.8 and 10.2 that satisfy these 2 inequalities, right? All right, the next, let me retype X. Now suppose you type X greater than 5, then you will get this, because when you type X greater than 5, what you are telling is that you're just trying to see whether each element in X is greater than 5 or not. So 1.4 is not, 2.7 is not, 4.5 is not. but the remaining data points are all greater than 5. So you get false, 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 and true, 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 right? So here, yes, it's just a logical operation, whether it's greater than 5 or not greater than 5, right? And you can assign the logical operation to an object, say LV. You don't need to call it LV, you can call it any other name, and LV will contain these values, right? All right, now let me explain what, the logical operations are. This means less than, right? Right, and this means greater than, right? And this means less than or equal to, I'm sure. All right, and this means greater than or equal to. Okay, and when you type double equal, that means equal to. Okay, and when you type like an exclamation mark and an equal, that means not equal to. Right, and when you type, and I have already mentioned this in just a minute ago, this means and, right? And when you type a vertical bar like this, it means or. And when you type an exclamation mark like this, it means negation or not. It is the opposite of whatever you're saying, negation, right? Okay. All right, so these are the logical operations, or the operations that are used in R. Okay, and it's very easy to, it's very easy, not difficult to remember them. Okay. Okay, now let me talk about some Boolean operation. Suppose C1 is a vector containing true and true, right? And suppose C2 is another vector containing true and false. Now, if you type C1 and C2, you will get this vector because true and true, I'm sure you guys have done Boolean algebra, haven't you? True and true is true, whereas true and false is false. Yeah, and whereas if you type C1 or C2, you get true and true, because true or true is true, true or false is truth, right? I'm sure, right? I'm sure you have done. And also if you type negation of C1, you will get false, because the negation of true is false. The negation of true is also false, right? And similarly, if you type negation of C2, you get false and true, yeah? So the negation of true is false, the negation of false is true, right? All right, now let's go to page 6. So can we, let me go back to the website. Okay, this is the course website, and right now we have 2 exercises that we need to do. This is exercise 1, this exercise 2. Okay, so let me tell you how. Let me take you through exercise 1 first, right? Okay. So let's start exercise 1, right? Now you have 2 vectors, y. Y is a vector containing these elements 1, 2, okay. And z is a vector containing the elements 3, 4, 8, 9, 15, 18, right? Now the first part is to find y minus 3, which is easy, right? So you subtract 3 from each element of y. The second part is to multiply z with 3 and add 1. So you get 3, you get this, right? So you're multiplying every element of Z with 3 and adding 1. The next part is to find the median. Remember, the median is the middle number. So the median of Y is 4 and median of Z is 8.5. And the next part is to find the sum of Z, sum of the values in Z that are greater than 10. That's easy to see because there are only two values in Z that are greater than 10, namely 15 and 18, right? Okay. There are only two values in Z that are greater than 10. And so if you sum them, you get 33, right? Median is a command in R. So median computes the middle value when you sort the data from the smallest to the largest micro, okay? All right. Now suppose the next part is to find the mean of the values in Y from the second to the fourth position. It gives you this, because if you look at Y, the data from the second to the fourth position are these ones, 2, 4, and 12. And their average, if you take the average of these three data points, you get 6, right? Okay, the next one is the mean of the values in Z, excluding the data from the fourth to the sixth position. This is what you get. The reason for that is this, because if you exclude the data from the fourth to the sixth position, that is, if you exclude these three data points, right, then the mean of 3, 4, and 8 is equal to 5. You see that? So when I say minus 4 to 6, that means we are excluding these three data points. All right. Now next is Y plus Z. Y plus Z is undefined because remember Y is of length 5 and Z is of length 6. So you cannot Y and Z are of different lengths, so you cannot add them, right? Okay. Remember, you can only add two vectors if they are of the same length. But in this case, they are not of the same length. So you can't add Y and Z, right? All right. So the next thing is Y, sum of Y greater than or equal to 4. Now what you're looking for here is the number of data points that are greater than or equal to 4, which is 3. There are only 3 data points that are greater than or equal to 4, right? Whereas you should type this. That means this command here means a completely different thing. What it does here is to take the sum of the data points that are greater than or equal to 4. So that would mean 4 plus 12 plus 16, which is 32. And this command here, it computes the number of data points that are greater than or equal to 4, which is 3, right? So you see, although these two commands look similar, they mean two different things, right? Okay. You guys follow me or not, right? So the first command is the number of data that are greater than or equal to 4. The second command is the sum of the data that are greater than or equal to 4, right? Okay. All right. Finally, sum of Z greater than 5 and Z less than 12. So what means here is, here you're looking for the number of values in Z that are greater than 5 and less than 12, right? So once again, you have only two values that are greater than 5 and less than 12, namely 8 and 9, okay? Okay, so that completes exercise 1. So let's go back to the tutorial sheet. All right, so we're done exercise 1. The second exercise is this one, okay? So you have, these are daily closing prices. The first part is to enter the data. The second part is to find the minimum, maximum range and mean and the standard deviation and so on. So let's see how we can do this, right? So this is exercise 2, right? So the first thing I'm gonna do is to enter the data. So let me enter the data. So 38, 42, 44, 43, 46, 48, 52, 54, 50, 47, 48, 48. So this is the data that I have just entered, right? The second part is to find the minimum. So to find the minimum, you just say min, right? To find the maximum, you just type this. To find the range, remember the range is the difference between the min and the max. So this is the range. To find the mean, you just type the command mean. And to find the standard deviation, you type the command SD. All right. Okay, so that completes part 2. Now part 3 is saying that the first value in S is 38, but it should have been 48. So we want to change this number, which is 38 right now, into 48. The easiest way to do that is, remember S in brackets 1 is the first data point, which is currently 38. And we want this changed to 48. So what you do is this, right? You see what I've done? I have changed the first data point to 48. So you should not type S. You see the first data point has been changed from 38 to 48, right? So that's the easiest way to do it. Now the next part is to find the percentage of days when the closing price was less than 45 pence, right? All right, now to do this, all you have to do is compute the length of this. Remember, S less than 45 will give you true or false, depending on whether it's less than or not. And when you compute the length, it will tell you how many of the days had closing price less than 45. So you divide this by the length of S, and then you multiply it by 100. Oh, what did I do? No, I think, sorry, that's a mistake. That's a mistake, guys, sorry. It should have been this, right? You divide this, all right, this gives you the length of the data when the closing price was less than 45. And this gives you the length of the total data set, right, which is 12, right? So you divide this by 12 and then multiply by 100. So the answer is 25%. That is 25% of the days have closing price less than 45, right? Okay. So like, let me show you one more time. I mean, this command here gives you the number of days when the closing price was less than 45. So when you type length, of it, it gives you 3. There are 3 days when the closing price was less than 45. So when you do this, it is 3 divided by 12 multiplied by 100. So it's 25%, right? All right, the last part of exercise 2 is to use the diff command. Remember, S is this. Now, if you type diff, of S, you get this. You see what has happened. The diff takes the difference between successive values. So the difference, 42 minus 48 is minus 6. 44 minus 42 is 2. 43 minus 44 is minus 1, and so on. So it's the successive differences between the values in S produces this, right? And by definition, the diff is, the length of diff is always 1 less than the length of S. So you should type length of diff, you will see it's 11, whereas the length of S is 12. That's, all right, so because you are taking successive differences, the length is always 1 less than the length of S, right? All right, so that completes exercise 2. The next thing I'm going to talk about, guys, is how to read data. So you should go back to the sheet. You should go back to the tutorial sheet here, this one. I'm going to show you how to read data from files. So we've done the 2 exercises, all right? The next thing I'm going to show you is how to read data, all right? So to do that, let's open the data set. There are 2 data sets here. You guys okay? There are 2 data sets, the Moses data set and the opinion poll data set. So let me open this data set. So to read this data set, all you need to do is to copy the URL, right? And and then go to R and paste it. And then use the command read.table in quotes, and then you say header equal to true. I mean, the command header equal to true simply means that the file has a header. You see, there's a header for this table, for this file, which is called time. So you have to say, when you read that file, you need to say header equal to true, right? So this is what you get. So let me give a name for the data. So let me call this Moses, right? Now if you type Moses, you will get this. So you see, the first column is just a counter column, which you can ignore. The second column is the data that you have read, right? Which is time, right? So if you type Moses $time, it will give you the data that you just read, right? Okay. Okay. So the dollar sign is used to pick the column that you want, right? In this case, you only have 1 column, except for the counter column. You only have 1. So you just say Moses $, the name of the column, to pick the column that you want, right? Okay. Now there is an exercise. It's asking you to find the min. So it's asking you, if you look at page 8, the minimum of this data is 47.02. The maximum is this. The median is this, right? It's also asking you to, what proportion of the data are less than 47.5 seconds. So to do that, you use the length command one more time. So you say length of the data, which is Moses $time. When Moses $time is less than 47.5 seconds, right? And then you divide this by the length of the total data set, which is Moses $time. So this gives the proportion of the data when the time was less than 47.5. And it's also asking you for the proportion when the time is greater than 49.5. So you change this to greater than, sorry, excuse me. So this is the proportion of the time, that the time is greater than 49.5, okay. All right, so that completes that exercise. The next thing is on categorical data. Now, categorical data is basically like, for example, if you ask people whether they smoke or not, right, then the answer will be either yes or no, right? So So a data like this. So let me create this vector. So I'm just typing data which contains the values yes or no. I mean, this kind of data is pretty common in real life, you know. There are many questions you can think of when the data is either yes or no, right? Okay, so this is the data that I just typed in. So as you can see, right? Now, a way to summarize this data is to use the table command, right? So if you type table, right, it tells you how many of the responses are equal to no and how many of the responses are equal to yes. So there are 8 responses saying no, 7 responses saying yes, right? And you can also convert the data into a factor. Factor is similar to, so here what you have is a factor variable taking the values either yes or no, right? And you can also, like, if you look at the levels of the factor, currently there are 2 levels for the factor, either yes or no or yes, right? You can change the factors to anything that you like. So if you don't like yes or no, or you want to call it something else, like suppose you want to say you want 0 to correspond to no and 1 to correspond to yes, then you can use this command. Now, if you type response F right now, right, you will get this. So here 1 corresponds to yes and 0 corresponds to no, right? Because sometimes you don't like to deal with words. I mean, sometimes it's better to deal with numbers than words, right? So you can use this command here to convert words into numbers, right? Okay. Now, the final thing, you should go to the last page of the tutorial sheet. Let me show you. Let me go back to the tutorial. This is the last page. The last page. Here we are. All right. So this is an exercise. So it's asking you to read this data set and convert the labels into the. All right. Let me show you the data set first. This is the data set. So this is like a party. There are 5 different parties and people are voting for one of the 5 different parties. And currently they are coded as 1, 2, 3, 4, or 5. All right. So the purpose of this exercise is to convert the numbering into actual names, right? So 1 corresponds to conservative, 2 corresponds to Labor, 3 corresponds to Liberal Democrats, 4 to UKIP, and 5 for other, right? So let me show you how to do that. So the first thing you need to do is to read the data. So you copy the URL and you go to R, paste it, and then you say read.table in quotes, double quotes, you put this, and then you say header equal to true, because as you can see, the data set has a header. The data set has a header called party, right? Okay, so you read this and you need to assign it to an object. So let me call that object Paul. I mean, you can call it whatever you like. Okay. Okay, now if you type Paul, you will see these 2 columns. The first column is the counter column, which you can ignore. The second column is the one we are looking for, which is party, right? Okay. So you should type Paul $party, it comes up with these numbers 1, 2, 3, 4, or 5. So as I said, these numbers correspond to 5 different parties, right? So the purpose of this exercise is to convert these numbers into the actual names of the parties, right? So let's see how we can do this. The first thing you need to do is to convert the data into a factor, right? So using this command, right? The next thing you need to do is to find the levels of the factor. Right? There are 5 different levels for the factor, right? And the next thing you need to do is to replace the levels of the factor into actual names, right? So I'm going to replace 1. I'm going to replace 1 with conservative, right? 2 with Labor, 3 with Liberal Democrats, and 4 with UKIP, and 5 with other. All right. So you see what I've done. I replaced the labels 1 to 5 with the actual names of the 5 different parties. Now you should type polls, poll F, right? You will see this. You see, we have converted the numbers. We have converted the numbers into the actual names of the 5 different parties. Now you should type table poll F. You will see the summary. So there are 369 voting for Conservative, 314 voting for Labour, 75 voting for Liberal Democrats, 118 for UKIP, and 124 for other. All right, so this completes the last exercise. All right, guys, so now you have any questions on what I did today? We have a few minutes left. Come on, guys, don't be shy. Just feel free to ask anything you like. All right, good to know that everything is clear. So if anything not clear, just, you can contact me 24/7 by phone, by email, by Skype or Zoom. And if you're in Manchester, I'm also happy to see you in person. I know it's snowing outside today in Manchester. I don't know what it's like in other places, but I'm still happy to see you if you want to see me in person. All right. So I will post the video of this after within about, give me about half an hour, because it takes about half an hour to actually upload the video to YouTube. So in about half an hour, you should be able to see the video posted on the course website. As there will be, as I said, there will be 2 different videos, one for the YouTube, the other one for the UOM version, right? Homework, we don't have a homework, but you have the quiz. As you know, the quiz is due, the first quiz is due next week, right? This is quiz number 1. The deadline is 10 a.m. on 18th of Feb, which is the Thursday, next week, Thursday. So you read this problem and try to think about the answer, the correct answer, right? And you should log into Blackboard and enter what you think is the correct answer, right? Okay. If you need any help, let me know. But I can't tell you what the answer is, of course. But I'm happy to give you help if you need. So I will send you an email soon after the deadline to let you know what you got. The laboratory, there's nothing called laboratory here. Laboratory is just simply the tutorial. It's a different name for the tutorial, right? So it's just, I don't know why they call it laboratory. Right, guys? All right, guys, have a good day wherever you are, and I'll talk to you soon. All right, bye.